Hi folks, Ryan Adams here. Today I'm going to talk to you and walk you through how we can create a failover cluster instance in Azure on virtual machines. So we're talking about an always-on failover cluster instance, or FCI. We're not talking about always-on availability groups here. We're specifically talking about FCIs and how we can make that work. Now I'm going to put a link down here at the bottom for you of another blog post that has a really good walkthrough on how to create this. But I wanted to do a video on this because a lot of folks are visual learners. It's a lot easier to see the actual code that got ran and what order it got run in and where we actually click and find things. That tends to be very useful for a lot of folks. The other thing too is that we're going to add on to that article. So the article walks you through doing the FCI. What it doesn't talk about is the MSDTC and how we would handle that if we're using distributed transactions and we didn't want to lose those transactions in case of a failover. We want to make sure that it was also highly available. So I'm going to cover and talk about that when we get to that point as well. Now, as with every configuration, there's always some prerequisites, so let's talk about them. Because I've done some of them for us because we didn't want to sit here and wait for things like VMs to build and that kind of good stuff. So the first thing we're going to need is virtual machines, right? Now, we're going to build this FCI across 2 VMs. And we're just going to use these 2 VMs to support this FCI and support everything else that we're going to need to make this work. But they need to be part of a domain. That's one of our requirements here for this particular configuration. So we will go in and make sure that we've got 2 VMs. They are added to our local Active Directory. Now, I've already done that. The VMs are already created. The VM with my domain controller is already created. They're already joined to Active Directory. Those pieces are taken care of. There's only one thing that I really want to show you that you need to be very careful about when you create your VM that's going to be required for the MSDTC to work properly when you get to that point. So let's take a look at that. If I were to go in and just click add, it's like I was going to create a new virtual machine here. And it doesn't really matter what I pick here because we're not going to walk through the whole thing, but I'll just pick the SQL Server 2017 one out of the gallery here. And this is going to have Windows Server 2016 and SQL 2017 in this gallery image. And that's not really the piece that we're concerned about. What I really want to show you is when we configure the NIC card, there's one specific thing you need to make sure that you do. So I'll go ahead and hit create here down at the bottom. And I'll just give this a name. I don't know, RJ test. That should be fine. Type in a username. We'll just use that and a password. And I'm just filling this in order to get through to the next screen where we actually do the configuration. Let's see, I'll put a different subscription here. Throw in a resource group that I've already got. And we're not actually going to create the VM anyway. I just want to show you the actual configuration piece here. So we'll choose a size. It doesn't really matter what I pick. Now, as it loads this up, there's only one piece that we're going to look at, right? So by default, it kind of takes some liberties with your resource group, and it looks at some of the resources that you already have and attempts to go ahead and fill those in, which is done here, right? So it's already found one of my virtual networks that I've got in the subnet that's in there. What I'm really interested in here, though, is this piece here. This is my public IP address. So if I click on this guy, over here on the far right, you'll notice that we've got a SKU here, and there's a basic SKU and a standard SKU. And so this is, when I create this VM, it's going to create a NIC card, and the NIC card is either going to be basic or standard, and this IP address will be basic or standard. In order for the MSDTC to work currently the way that we've tested this, you need to have a standard load balancer, an internal load balancer at standard, and we'll talk more about that when we get to that point. But we can only add standard IPs to a standard load balancer. So when you create your VM, the only thing, everything else that you fill out and do is all up to you. I don't need to walk you through that. You just need to know that when you get to the public IP address, that you go over here and you click the standard button, making sure that you choose a standard IP address. That will be required later Once we get into some more of the configuration, we talk about the load balancer and all that kind of good stuff. So now I've already kind of done all of this stuff for us. That pretty much has all been handled. So let's go in and just take a look at the VM. So I've got a VM. I've got two of them, RA test 4 and 5. We'll do most of the configuration here from number 4. Now the first thing we need to do is add the Windows failover clustering feature once we've got our VMs up, right? So let's pretend we just created our VMs. These are brand new. We've done nothing to them. They're brand new right out of the gallery or whatever image we created them from. Now there's two different ways that we can do this. We can do this through the GUI. Pretty simple. If we're in Server Manager, all we need to do is add roles and features. This is a feature, not a role. So I'll do next, next. I'm on 4. It's not a role, so here's a server role. It's not one of those. So we'll skip by that, click next, we'll get into features. And so here it is, failover clustering. So failover clustering is installed. Now that's because I've already done it. That way we didn't have to sit here and wait for it. But this would be one way to do it. And when you check this box off, it will also pop up a dialog that says, hey, if you're installing this, there's some tools that go along with it. You might want to have those tools installed. Here they are. We'll go ahead and add them for you. And here's what it does. It adds the failover cluster management tools and the module for PowerShell. Now there are two others you'll see here that it does not add for you by default. If you are still using the cluster exe instead of PowerShell, which has been deprecated, so I suggest that you move on and don't use that anymore and get used to doing it all through PowerShell. You can still technically add that down here at the bottom if you want to. So the other way to do this, it's a little bit easier, is to use PowerShell to actually add this, right? So that's what these two lines here are going to do. And let's see if I can zoom in a little bit here. Let's make this a little bit bigger. And all I'm doing is throwing in my node names in a variable, right? So we're creating an array here, throwing RA test 4 and RA test 5 in this array, using the invoke command to do an install Windows feature. The feature we're going to install is Windows clustering. I want to include all sub-features and management tools, right? And so those are the add-on pieces. I told you to pop up that dialog box. That's what the sub-feature and management tools are covering. So if I run that, that will actually install on both of my nodes, which is awesome because I can be here on one node and I can run this and it'll do the install on both nodes, and then I'll take care of that. Doesn't cause a reboot or anything like that. They're all good to go. Now I've already done that stuff. That piece has already been taken care of for me, so I don't really need to worry too much about it. So now that the feature exists, now we want to validate that the configuration that we have is actually going to work. So we can do that here, and you can do that going through Failover Cluster Manager as well. I'm not going to walk you through that, but if you want, you can certainly do it that way. I'm using the test cluster module out of PowerShell here. I'm giving it the names of my nodes that I want it to test as part of my FCI configuration, and I'm telling it to specifically include these pieces. If you leave the include off, it'll do everything. But I'm wanting to make sure that I specifically look and validate these pieces. So I can go ahead and run that. Now, it doesn't take too awful long to run this. Every configuration, and depending upon the size of VM and how fast your VM, your mileage may vary, right? So when it runs this, it stores all of our reports in the same place for any and all clusters, right? And this is the same for any cluster. So if we go into our C drive, we go into the Windows directory. We're going to find a cluster folder here, and there's a reports folder. Now, this is obviously I've been testing and doing this quite a bit, so you won't have as much stuff in here. But what it's going to do is it's going to create a validation report down here. Now, right now, you can see that I've got two here, April 26th and April 27th. It's still running the one that I'm currently doing, but it'll pop in here with one for May 1st. And then we'll be able to open that up and look at that. Now, that depends on what this comes back with, right? It may come back and say everything's good, or it might not. And so we've got some results here. System configuration, validating software update levels. There's some warnings here. Network communications, there were some warnings. So it completed successfully, and it says that the cluster is conditionally approved, meaning that I didn't have any actual hard errors that would prevent me from creating this cluster. But I did have a couple warnings that it was concerned about that I thought that I should probably take a look at and just make sure that they're okay with what that was. So let's take a look at it real quick, because you very well may run into this yourself. So let me scroll down here, and here's our new report here, May 1st. Let's open this guy up. And let's go full screen here so we can see. So we can see that I've got the inventory was fine. It came out green. My storage spaces came out green. It was perfectly fine. But here on my network, I had a little bit of an issue. I had a warning here. So let's take a look at that one first, and then we'll look at the system config. So validate network communication. We'll click on that. That's where our warning is. And what this is telling me here in yellow is, hey, you've only got one network path between these two servers, and that's not a best practice configuration by any means. You should really have multiple networks. I don't have that here because this is just a test environment. We're just playing with this. In production, by all means, you should absolutely have more than one pair of network interfaces in a cluster. You should have your public traffic and your private traffic completely separated from each other. They should be on their own networks. And you should also have any availability groups, which we're not using today. We're using FCIs. But if you did have an availability group, you would want to take that replication traffic on the endpoint transports and make sure that those were also separated on their own IP addresses. But for our testing purposes today, this is perfectly fine. We're just trying to show you how to build one. Just note that if you run into this, this is something you'd want to repair. You want to go add some more NICs to these servers in order to have redundant paths between them. But for us, we don't really care for our purposes today. System config, this is just update levels, right? And these are brand new VMs. They just came out, and basically all it's saying is, hey, look, this server's missing some updates, and this guy's missing some updates. Ideally, you want your cluster nodes, whether it's an FCI or an AG, either one. On the Windows side of this, we want to make sure that our updates are exactly the same. And it's just saying, hey, look, I found some patches on one that are missing on another one. You need to go resolve that. Again, not enough to prevent us from creating our cluster, and that's perfectly fine for our testing purposes here today. We don't really care. But just make sure that if you run this and it comes back with any types of warnings, that you go look at those and validate whether those are okay for your specific configuration or not. If you're unsure, make sure that you seek some help to find out whether you're doing it right or not. The one thing I can tell you from experience is getting the cluster right, especially when you're putting an FCI or AG on it, is absolutely paramount to your success and to either one of those technologies working correctly. If you get it right the first time, you'll have far less problems in the future. So for our purposes here, we've run this test, and we're okay as far as we're concerned. So now what we really need to do is we just need to go create the actual cluster itself. And again, I'm going to use PowerShell in order to do that. So I'm going to do new cluster. I'm going to give it a name. We're going to call it RAWSFC. RA is my initials, Ryan Adams. Windows Server Failover Cluster is WSFC. Just picking a name for our testing purposes doesn't matter. I'm going to give it the nodes, node 4 and 5. I am going to provide it a static IP address. Now, that's two important pieces to note here, especially in Azure. Because of the way that this works with DHCP, if you use DHCP, your cluster, because this is when we create this cluster, this is going to create an object in Active Directory. The cluster itself is going to have an IP address. If we use DHCP in Azure, it will automatically grab the same address that the local server has. Well, obviously you can't do that. Otherwise we have an IP conflict on the network. It has to be different. So we need to specify a static IP address here. So make sure that you're doing that and you are giving a static IP and not using DHCP when you build your FCI in Azure. Here's the other thing that's a little bit interesting, and this may be a little bit new to you, not the no storage part. Now, that's just a test that I'm ignoring here, but the management point network type singleton. Now, depending upon when you watch this video, I'm using what we call RS5, which is a newer Windows Server release. And although I can't talk a whole lot about the release at this particular point in time, just note that out of the box, it uses a DNN. And this distinguished network name means that for our cluster, we don't actually have a network name and an IP address assigned to him. but that does not work well with SQL Server at this particular point. I suspect that by the time this goes GA that may change. So I just want to make sure that I'm pointing this out. So what I'm telling this to do is to use the old method, and I'll point this out when the FCI is actually created and we can see it. It's saying, hey, go use the old method, give it an IP address and a network name that I can use instead of using this new DNN. Okay, that is something that when you go to install SQL Server, that SQL Server is looking for. It does some checks inside the registry to make sure that that exists. So because I'm using a newer build of Windows, I need to make sure that I tell it to use the old style. Now again, once this comes out GA, this software is not GA right now. This is considered preview and pre-release software. That very well may change. But I just want to point that out now. So let's go ahead and run this line. And that's going to create the cluster itself. So the cluster is actually going to take a minute to go ahead and run and get created. So I'm going to go ahead and pause the video here. That way we don't have to sit here and wait for the build. And then we'll join back together in just a minute once the build is done. Okay, so the build is now completed. And again, just like we saw when we did the test, we do have a couple warnings here about the actual creation of the cluster. So we should really check into that and validate that just to make sure that everything's okay for our purposes here. So we'll go back into See Windows, Cluster, Reports, same folder we were at before, and we're going to take a look at the actual cluster creation log. And it gives you the full path down here. So for mine, it's Create Cluster Wizard, and it's May 1st, right? So this one here is the report that it spits out. So scroll down here till we find something in yellow, and it says, hey, an appropriate disk was not found for configuring a disk witness. And so that's true. I have a 2-node cluster at this point, but that's an even number of votes if you think about it, right? We need another piece of arbitration in order to take care of quorum. Now, for our purposes today, I'm not actually going to walk through doing that because that's not what we're trying to prove and show here. We're just trying to get through how we would actually do the build. In real life, in your environments, we need to actually have another odd number of votes. So we want to make sure that we're using a disk witness. Now, that's disk witness. And we could also use a cloud witness or a file share witness. So no big deal for us here. That doesn't prevent or stop anything. If I open Failover Cluster Manager and I connect, I should be able to see what it looks like, and it should exist now. Indeed, it does. So I know that some of this looks a little blurry, and that's just because this is a pre-release build of Windows Server. So it's the code still being worked on. So some of the graphics here are a little hard to see, but I'll at least try and zoom in where we can. Now, here's the actual name of my cluster, right? RAWSFC. It's currently running on node 4. Remember, I've got 2 nodes in here, node 4 and node 5. So I'm currently came up on node 4. Here are the actual resources for the cluster itself. So I can see that it does indeed have an IP address and a network name. You won't see the IP address if you're using the DNN. So if you don't see this here, SQL Server is not going to install. Again, may change by the time we get to, and I'm not using a pre-release version of SQL Server here. This is, and I've tested this on SQL Server 2016 and 17 both, full versions, right? They're not pre-release. We're just talking about Windows Server here as a pre-release. And the reason we're using this pre-release is because that's going to be required for the MSDTC. And I'll talk more about the versions there in MSDTC when we get to that point. So everything looks good there. Obviously, I'm not going to have any roles. That's empty. I do have some nodes here. So I've got node 4 and node 5. So all of that appears to look good. That's pretty much the way that I would have expected it to be built. Now, with a failover cluster instance, one of the requirements for that is to have shared storage. Now again, this is typically for a high availability type situation, and there's obviously some trade-offs here. The drawback to it is with shared storage, I have a single point of failure, but I can also fail over really fast between the nodes because that means I'm redundant against the operating system, the physical piece of hardware or VM, however that may be, at the host level, and also against SQL Server binaries and all that kind of stuff. So it's an excellent HA solution, but I need to have that shared storage, and that's where things got a little complicated. On-prem, it's pretty easy if I've got some type of SAN, iSCSI or something like that. It's pretty easy to do. In Azure, there wasn't really a native way to do this. You can add drives to a virtual machine, which I've done. So one of the other prerequisites, and I apologize, I forgot to mention, is when you create your VM, and no harm, no foul, if you already created them at this point, you can go back and add them, is that you need 2 data disks per VM. And that's for the step that we're going to do now, is taking care of the shared storage. Now, there were other vendors and partners of Microsoft that had other solutions using iSCSI and some other software-based solutions that work with this. But as far as a native Microsoft Windows solution, what we're going to use is something called Storage Spaces Direct. And that basically allows us to think of it as a RAID. It allows me to take the fact that I have added 2 data disks to both of my nodes here and essentially create a quote-unquote RAID between those disks and use it as shared storage. And I present that to the cluster as a clustered shared volume. And so that's what we're going to go ahead and take a look at now, is how do we handle that? How do we do that? Now, again, I've already added data disks to this machine, both of these machines, to use for this. They each have 2 disks. So how do we handle that piece? Well, the first piece is we need to go ahead and make sure that we turn S2D on. But one of the things about S2D that we need to make sure that we really get right before we go turn it on and start creating pools and adding all of our stuff is we need to make sure that those disks that are attached, they need to be completely clean. They need to be wiped off. They shouldn't have volumes on them. They should be in a raw format. And so I've got a piece of PowerShell code here that's going to go take care of that for me, and I'll go ahead and run that now. Now, the link that I gave you at the beginning has a link to an article with this code in it. So you'll be able to have access to this code. And all this does is it goes through and takes a look at all the disks, anything that is not primordial. We go ahead and wipe it out and make sure that it's all set and ready to go. So I'm going to go ahead and pause there for a second while we make sure that all of those pieces are good. And I need to go run this on the other side so we don't have to wait and watch that. So hang on and we will be right back. Okay, so we're back and it finished. You'll notice down here at the bottom, it shows that I have a count of 2 on both server 4 and server 5. So like I said, we've created 2 data disks on each node in order to use for our storage spaces direct. So now that we've cleared those off and those are good to go, let's go back and actually enable storage spaces. We'll just run enable cluster S2D, and that will turn storage spaces direct on for us. Are you sure you want to perform this action? Yes, we do. And that's going to go turn the S2D feature on for us. And once we do that, there's one thing that we'll be able to see inside of the cluster that's been made available to us. Now, by default, what this is going to do is it'll find all the available disks. In fact, even down here at the bottom, you say disk not claimed, right? It's going to grab all of those and create one logical volume between all 4 of those disks, 2 on each node. It will put them by default into a single pool. Once we have the pool and it's done creating that here, then we can go in and we can divide that logical volume up into other volumes that we need. And we can see all of that here in storage. The first thing we'll see is, when it's done, is we will see enclosures in here. And for us, this time, and it is actually done now, the enclosures that we're going to see here are the actual virtual machines themselves. So we'll do a refresh here. and it usually takes a second to populate that, although you could already see the pool, right? So it's already created the pool, but we don't have any disks. We have to carve disks out of that pool. And so I'm going to do that here again, all in that link that I sent you. All the stuff is in there. I'm going to create 3 of them. I'm going to create one for my SQL Server data files at 800 gig. I'm going to create one for my log files, and then I'm going to create one specifically just for the MSDTC. Now, I just picked sizes here because I've got the storage. MSDTC, you don't need 200 gig for. That's insane for MSDTC, right? You would need like 500 meg at best. It's really, really small. So clearly we're overkilling that here. But again, just for demonstration purposes, let's go ahead and run this first line. And this is going to create and label it as labeled data with our friendly name here, an 800 gig volume that is going to carve out of this pool. And you can actually see it. It's already doing it now. Okay, single pool here. And as we create the disks, we'll start to see them populate in here. This is the one that we created just now. This one here is actually created by default, and this stores performance data in the cluster of itself, and that's something else new that you will see in this version of the OS. So it's already done with that. We're going to create another 800 gig volume. That guy is going to be for our log files, and then we'll create one for the MSDTC. So we're using Storage Spaces Direct, which uses the SMB protocol. There's a lot of good research if you're going to use this that you should do around this to understand how to properly use it. It does use SMB 3.0, but there are some other specifics around NIC cards and things that you're using, how we bind those inside of the cluster, things that I don't have time to cover today that we can cover at another time, as far as how they're bound on the network stack. I'm going to run this other one while I'm talking, and that kind of good stuff. As far as RDMA, the versions and things that it uses there to get the best performance out of it. So there's definitely some research in that. We're using, in order to create this architecture of an FCI in Azure, we're using a lot of different pieces of technology in order to make this stuff work. So it's very interesting how we end up using all this stuff. So now it's done. And I can see again, here's my data, here's my log, and my MSDTC. So all 3 of my volumes have now been created, and I'm ready to use them. Now, because we're using S2D, when we use storage spaces, and again, S2D is just another term for Storage Spaces Direct, so I may use those interchangeably here. When we do that, it presents them in the cluster as what we call a clustered shared volume. And CSVs are pretty cool, because what happens is there's this cluster storage that it creates right here in the root of the C drive, and it essentially creates mount points. But what's interesting about these is, and again, a whole other technology for a whole other day, is I will see this same cluster storage on the other node, and they can both be accessed at the same time. And the idea originally behind this was for Hyper-V, because if I were to fail over, say, a SQL Server failover cluster instance now with its storage, we have to fail that storage over to the other node, and we have to bring it online. With a clustered shared volume, we don't have to do that. These things are available to both nodes at the same time. And if one goes down, it'll even redirect the traffic through another operational node, which is some really cool stuff that's worth taking a look at. But for now, I've got my volumes here, my data, my log, and one for my MSDTC. So that's great. I can see that. I can see that here in Cluster Manager. So all of those pieces are really good. They're exactly how I want this stuff to take a look. Now, my next piece is going to be, my cluster is done. We've built the cluster, all the pieces that we need here, the building blocks exist. Now we need to layer SQL Server on top of that and actually build our failover cluster instance. So if we open up the SQL Server install, go to installation, and we're going to do new SQL Server failover cluster installation. Okay. Again, that's the difference, right? If this was an availability group, I wouldn't be picking this, right? This is, again, always on FCI specifically that we're talking about here. And this is what we're going to choose, SQL Server Failover Cluster Installation for the first node. So let's go ahead and do that and get the install for SQL Server started. And I'm not going to make you sit here and wait for the whole install to go through, but I do want to at least get through this far enough to show you where I define my data file and log file and tempdb and all that other kind of good stuff. So we already know when we created the cluster that there were some warnings in there, and this is just again telling us that there was a warning. If there was an error, SQL Server would actually stop right here, and the next button would be grayed out. You can't go any further. It would be unsupported. I'm just going to use developer edition eval. It doesn't really matter. We're just testing here. Set my license. Just going to throw the engine features on here. We're not going to do integration services, now services. We're not going to play with any of that kind of stuff. Just doing the engine. And then it should ask us and start getting into the pieces of the cluster. So it says, hey, what do you want your network name? Now, something we're going to register in DNS, something we're going to have an IP for. Somebody's going to create a computer object in Active Directory that we need the rights to be able to create, or we need to pre-stage it. So let's go ahead and call this SQL FCI 1. Real imaginative, right? Default instance is what we'll go with. By the way, let me interject a common misconception. I see a lot of folks here. They think that because you are on a cluster that you always have to use a named instance, and that's not the case. Your first instance can definitely be a default instance. It makes life a little bit easier to use a default instance with the default ports from a connectivity standpoint. So if this is going to be your only clustered instance, I would totally recommend doing a default instance. So now it says, what drives do you want to use? Now, this is super important because I ran that PowerShell code and called it data and called it log. If you don't give it a friendly name, it picks a giant GUID. And it makes it really hard to figure out which drives are which drives. But fortunately for me, I labeled them, so I know exactly what I want. So I'm going to grab my data and log drives. We'll check those off and say those are the ones that I want to be able to use for my SQL failover cluster instance. It says, hey, what about an IP address? So we'll go ahead and put a check mark in the box. We do not want to use DHCP here. We're not using DHCP for the exact same reason that we didn't use it for the cluster. In Azure, it's by default going to go ahead and grab the IP address of the local node, which is going to be a conflict for us. So I'm going to give it my service account. Going to grant it perform volume maintenance tasks. Not worried about collation for this. Add myself here as an admin. We'll leave it Windows off, it's fine, but the data directories are where things get interesting. So because I chose different drives to put stuff on, I'm going to go ahead and leave this as my data root directory, which is fine for my system databases. My user database directory, that's fine. It's going in cluster storage data. But the log directory, that's different. That's a different volume. That's on C cluster storage log. And then, of course, the destination folder at the end here shouldn't be data. It should also be log. Same for tempdb. We're going to want to do the same thing here. And you may want to create, best practice would say, hey, look, I want to separate this out. I want to put tempdb on its own drive, so I'd probably have a whole other third volume that I would use for tempdb. For our purposes today, though, we're just going to go ahead and stick with just these two drives. So we will redirect the tempdb log file to a different drive. And we'll go ahead and click install. So at this point, I'm going to go ahead and pause the video so we don't have to sit here and wait for the install. And then we will join back together once the install has completed. And we'll finish taking a look at the rest of the pieces to configuring this architecture. Okay, so we are done with the install. While the video was paused, I went ahead and did the install on the second node as well. And what I'll just show you here is when you start the installation on the second node and any subsequent nodes of a failover cluster instance, our choice is going to be add node to SQL Server failover cluster. It's a very simple install. It pulls all of the required information that you need out of the registry from the initial node that we would have created. Really, the only thing you need is to enter is the password for your service account. So I've already done all of that, so we don't have to worry about it and sit here and watch the install of SQL Server. And our result is this. I now have a role for SQL Server. If I look at my resources, I'll see all of my resources. Right, here's my, well, actually, let me expand that. I've got my network name sitting here. Remember, we called it SQL FCI1. I've got my IP address that I gave it. Here's the SQL Server resource. Here's the SQL Server agent resource. So we've kind of got all that stuff. Now, the one thing you might notice from doing a traditional FCI on-premise is on-premises, you've got storage sitting in here. Now, we know we gave it storage, but you just don't see it in here. So that's one thing that's a little bit different about this is when you're using S2D, when you're using clustered shared volumes, it doesn't appear as attached storage within the actual resource group itself. Obviously, we can go see the disks. All the disks are here. In fact, even if we go out here and just take a look at them, like let's take a look at the data volume. There's the install folder for SQL Server. Here's SQL. If we go into the data folder, here's all of our master model MSDB and TempDB databases that we created. Right, same for log and all that kind of good stuff. Again, on the log volume. And MSDTC we'll get to in a minute. So at this point, we've successfully created a failover cluster instance in Azure with a SQL FCI on top of that Windows Server failover cluster instance, using storage spaces direct as our shared storage. So everything looks great. There's only one other little catch. It's a little bit different in Azure that's different than on-premises. And that is, normally, typically, we would be done on-premises. Because our role here, this failover network name and IP address would be perfectly fine to connect to. But in Azure, the networking is a little bit different, and we actually have to create an internal load balancer in order for this to work. So let's go see how that looks. So I'm going to go back over here into Azure, going into the resource group where I've created all of my resources for this configuration. I'm going to go ahead and click Add. And what I want to add is a load balancer, so I'll just type it into the search here. Load balancer, great. I'm going to go out here and find it. Here's the load balancer here. I'm going to go ahead and click Create. And I'm just going to use my initials, RA, LB for load balancer 2. And then we have a few choices. So the first one is internal or public. And for this, we're going to need an internal load balancer because we're load balancing the traffic internally inside of this VNet in Azure, not traffic coming out from the internet. Now, this is the other thing that's important. For the MSDTC, we want to make sure that we're using a standard SKU, not a basic. And then we need to choose a virtual network, and this virtual network is going to be the same VNet that you created your virtual machines on. For me, test MSDTC2 VNet is the VNet that I used. Pick a subnet out of there. I just have a single default subnet to use. And then we need to give it an IP address. So I'm actually going to fill in. I'm going to click the radio button here for the static IP address, and then we'll put the IP address in here. Now, the IP address that has to go in here is the same IP address that you use for your FCI network name. So going back in and taking a peek inside the VM, that's this guy here. This is the network name for it. This is the IP. So 10.0.110 is what we're going to use. So we'll stick that in here, 10.0.110. So we can make this zone redundant and choose whatever zone we want. We're not going to play with availability zones today. Put it in our subscription that we choose, and then I'm going to put it in the existing resource group, the same resource group that I've used for everything. All of my nodes and VMs that I've created, all those resources are all in a single resource group, so I'm going to put them in there. And then pick a location. I'm happy to put these in West US 2. Go ahead and hit Create, and that's going to go out and create our load balancer. Now, that creates the load balancer, but doesn't really configure the load balancer, just creates it. There's some pieces inside of it once it finishes deploying here, which is pretty quick at creating the load balancer. We've got to go in and define. So we've got to go in and define things like the backend pool and the probe port and those types of things. So we'll walk through each of those pieces, and we'll actually end up doing it twice because, and there it is, it's done. Hit go to resource. We're going to have to do this again for the MSDTC. We haven't gotten to that piece yet, right? We're going to come back and do that at the very end in order to add the MSDTC. But we set the stage right. We made sure that we picked standard for the load balancer and standard for the IP addresses for our VMs in order to make sure that this is going to work right. So let's go in and take a look at the backend pool. Let's create the backend pool first. And I'm going to click Add. And we'll just call it RA Pool. Give it a name, whatever you want to name it. And then we need to pick our virtual network. And for me, of course, I just have the one, the test MSDTC2. And then we add each individual virtual machine. So I'll check this off and we'll add the VMs. Now for us, we're using RA Test 4. We're also using RA Test 5. Then once you select the virtual machine, you select which IP, and they just both have one. Again, standard IPs. If you don't have that, if you created basic and this is a standard pool, a standard load balancer, none of these stuff will be here in the drop-down box. It'll all be empty. So you'll know you've done it wrong. If you go in here, you'll have missed a step. Something's not right. You probably picked basic somewhere if this stuff doesn't show up in here. So that's pretty easy for the pool. Not a lot to do there. And remember, what we're doing is we're saying, as traffic comes into the front of this balancer, where is it going to go on the back end? And so the back end is going to be my two nodes in this case, 4 and 5. So that looks good. So let me tab through here until it So after you click Add, it's going to go through and finish doing its deployment there and putting the backend config in there. So now let's take a look at the probe port. And the whole idea behind the probe port is it is supposed to, as traffic comes into the front of this load balancer, it has to direct it to whichever node is active at any given time. So we need to make sure that we have a probe port to point to that. And you'll have to do this. So if you have multiple instances of SQL Server or any other roles or multiple roles in here, for every one of those network names that we have, we're going to need a new probe port in order to follow that around and direct that particular traffic. Let's call this RA probe. Actually, you know what? This probe is going to be for the FCI, so let's call this RA probe FCI. And then we've got to fill out the interval, the unhealthy threshold, and the port, and all that kind of good stuff. What we're really concerned about here is the port. And what we want to do is we want to pick the port here that we're using for SQL Server. And so what we're going to do is I'm going to use 59999. Now this isn't the SQL Server port, not like we create a default instance and SQL uses port 1433 by default. That's not what we're using here. You can use any port that you want to be able to use here, but we just want to make sure that we're picking usually some high-end ephemeral port in the high range. So I'll just use 59,999. Interval and threshold are perfectly fine for us here. Those defaults are fine. We'll go ahead and click OK. And that will take care of the probe port. That way it can figure out which one's active. And then the last piece we need to do is look at this load balancing rule here and actually create the rule that takes the backend and the probe port and joins them together. So let's click Add. And of course, it says a probe must exist, so it hasn't finished deploying the probe yet, apparently. Let's go take a look at our status here. Oh, now it has, so it's created the probe. All that stuff's good. So let's create the load balance rule. And let's call it RALB rule. IPv4, it wants a front end. So our front end here is going to be SQL Server. That's our FCI, right? The 10.0.0.110. That is the IP address that will be coming in, the traffic incoming we'll be looking for on the front end. And then we can choose our protocol port here since we happen to know what that is. And for us, the port is going to be 1433 on the front end and the back end, right? Clients are going to come in with 1433. They're going to come out the back end to SQL Server on 1433. So those ports are perfectly fine. And then we're going to pick our backend pool and our health probe. Now, of course, there's only one backend pool. We can see it has our 2 virtual machines in it. And there's the one probe port, it's the only one that we have. So all of that stuff is perfectly fine. We'll do none for session persistence. Default timeout is perfectly fine. And this floating IP direct server return, we need to make sure we turn that on. So for SQL Server and our MSDTC, we need to turn this direct server return on. So we'll go ahead and click enabled on that, and then we'll go ahead and click OK. Now, that finishes creating our load balancer for SQL Server, but we need to make sure that we actually configure that inside the cluster as well. So let's go back into our VM here, and let's open up PowerShell and take a look at this piece of code. Again, all this at the address that I gave you at the very beginning of the video. This is where you can find all the links to all of this stuff, all the code, and all that kind of good stuff. Now, there's a few parameters that we need to fill out here first in order to make sure that we run this. And what we're doing is we're configuring the IP address, this one, 10.0.0.1.10. We need to tell it what the probe port is that it needs to be listening on. So we're going to go ahead and do that here through PowerShell. Now, it needs to know what the name of the cluster network is. Now, for us, I didn't configure, according to best practices, our network, right? But I would go into Properties, and Cluster Network 1 is what it's called. So that's fine here. We'll use Cluster Network 1. And it says the IP resource name. Well, it's not 10.0.0.0. It's actually going to be 10.0.0.1.10. Right? Again, that is going to match this IP address right here. Make sure we're matching that for our FCI. So now we know we have our IP right, we have the network name right, and then it wants to know what is the ILB IP. So again, that's the same IP that we used. It's going to be 110 as well for this particular piece. And then it wants to know what the probe port is. And my probe port that I chose was 59,999. So now we have all of our variables set correctly. We'll import the module for failover clusters, and then we'll actually go out and set that resource, and then we can check it at the end. And since I change this, we'll make sure we're doing that right. And all right, we pass in the ILB IP, we pass in the probe port, we know what our subnet mask is, cluster network name, and DHCP, of course, will be turned off, 0. So let's go ahead and run this. So it looks like we got an error here running resource IP address 110. So we need to go figure out what's happening with that IP address and why we're not finding that. Now, this is a pretty common thing that we run into here, because all I did was go in here, oh, my IP address is 10.0.0.1.10. Well, that's not actually the name that's stored in the cluster. So if I go down and I take a look at the properties here of this guy, we'll find out that this is his actual name. Let me just copy that out of there. We can go fix that problem. Stick that in there. And so now we know that we've got our cluster network name should be right, and we now finally have our IP resource name right, our ILB IP, our probe port of 59,999 that we used. One of the things I wanted to re-point out too on the subnet mask here, you do need to use 255, 255, 255, 255 as the broadcast in order for this to work properly. So now, let's run it again and see if we have a little more luck this time. And so as it turns out, everything's fine. it worked. But it does tell me that not all changes will take effect until the IP address is taken offline and then back online again. And then if I wanted to confirm this, let me just copy this out and put it in here. So we can do a get cluster resource just to show that that actually did indeed work. Everything looks as expected, right? Right here is our probe port. So we've now configured our probe port as 59,999. So we know that that worked correctly. That's in there. But in order for it to actually work properly, we're going to have to take it offline and back online. Well, of course, in order for us to do that, either we would have to, you're going to incur an outage here. The easiest thing to do is to just fail this over, right? So I can fail it over and then we can fail it back. That's usually the easiest thing to do. You could get fancy if you didn't want to take SQL Server offline. You could break some of the dependencies here, so you could just take the network name offline. But that's generally not recommended because you have to remember to put it all back and get it right, and it's easier to just kind of fail things over. So I'll do that. I'll go ahead and move, and that will fail everything over. So I'll go offline and come back online. We'll move that over to server 5. If I want, I can bring it back to server 4, or I can leave it wherever it is, and life should be all good. And then we can just prove that we can connect to it and that it's actually working right by going to a client machine. So if I come over here, I use this as my client machine. And this was connected from earlier, so we'll disconnect and reconnect again. SQL FCI1, that's what we called it. And there we go, we connect in. Of course, we don't have any databases, there's nothing going on here. We're now able to connect in properly. And we can even do a like that at server name here if we want, just to verify. So this is common. Let's see if I can remember the full thing here. Select server property. I believe it is computer name physical net BIOS. Hopefully my memory does not fail me here. It does not. So that's great. We can see that yes, indeed, I do have. Sorry, I hit a key there. I am running on RA Test 5. And just to make sure that it is legitimately successful and all that good stuff, let's fail it over again. And we'll fail that back to 4. Once everything comes online over here, we'll make sure that we can indeed do that. You'd be surprised if you're used to using clusters and SCIs and AGs, how many times I see people set these up and not to test a failover even right out of the gate. Please make sure you do that. So let's go ahead and execute this again. And now I can see down here, I do indeed, I'm back on RA Test 4. So I'm able to connect successfully even through a failover. Everything works great. So we've now successfully created a 2-node failover cluster instance in Azure using Storage Spaces Direct through it being presented as a clustered shared volume for our shared storage, put a SQL Server failover cluster instance on top of that across 2 nodes, created our load balancer, configured our backend pool, created our probe port, the front end, all that stuff's been done and tested an actual failover and connection from a client standpoint. So we know we've got a good, solid running thing here. Now what we want to do is look at the MSDTC. That's the tricky piece we haven't really gotten to yet. Now, let's go through here and just right-click roles, do configure role. I'm going to choose distributed transaction coordinator here as a role that I want to configure. Now I need to give it a name, and let's just call it Clus for Cluster DTC as a name. And then it says, where do you want me to put the storage? Now, this graphic looks a little messed up. Some of the icons are messed up, and that's just because we're using a pre-release version here, right? This is just in preview. But I'll check my checkmark box off for the one MSDTC. Again, good thing I labeled it and didn't have a giant GUID there, right? When it comes to clustering, please label everything. You'll thank yourself when it comes time to troubleshooting. And I'm talking about label your NICs, label your networks, label everything. This way you know where everything is at. So super easy, MSDTC, I'm going to choose that. That's where we'll put it at. Here's everything that it chose. We'll go and do next. Now, here's what you're going to notice. It did not give me an opportunity to choose an IP address. It automatically chooses DHCP on my 10.0.0.0.0 network. Now, when I click Next, and then I click Finish, what's actually going to happen here, you'll see it's creating it, right? And as soon as it creates it, it's pending. It's trying to bring it online. It's not going to succeed. It's going to fail. Because the IP address it's going to get using DHCP in Azure is going to be the same IP address as the server that it's running on. I can see the owner node's RA-test4. It's going to get the IP address of RA-test4. That won't work. That's a conflicting IP address on the same network. We can't do that. So I'm going to do I'm going to click my IP address down here and do properties, and we're going to go give it a static IP. Click static down here, and I'm just going to give it 115. We'll go ahead and click OK. It's going to save this. Now there's a chance that depending upon where it is in the process, because it's still trying to bring it online, I may have to do this twice depending upon where in the process it is. Hopefully we did this fast enough that it'll just go ahead and take. If it doesn't, you just have to wait until it fails, which it will do, and it'll be all offline, which is fine, and then go ahead and make the IP address change and then bring it online. So in between retries, before it did a complete failure, I was able to make that change on the IP address. The IP address is now legitimate. We have no more conflicts, and it came up just fine. So that's great for running the clustered MSDTC. Now note, starting in SQL Server 2008, you no longer have to create a clustered MSDTC. It used to be required if you created a failover cluster instance of SQL Server, you had to create a clustered MSDTC, and we stopped requiring that. Just because that is no longer required doesn't mean you don't need one. There is a local MSDTC on every machine, and it will use that by default. But if it fails over from that node, let's say I'm running here on node 4, and I fail over from node 4 to node 5, what do you think is going to happen to that transaction that's running on a local MSDTC on this node? What if this node had a blue screen? That transaction just went bye-bye because we didn't have that set up to be highly available. So a lot of folks are confused thinking, oh, I don't have to create an MSDTC anymore. The local one takes care of it for me. No, we just removed the requirement because there are workloads that folks run that don't use an MSDTC. So why have one and have to create one if you're not even going to use it? But if you're going to use one and it's in a failover cluster instance, you should be clustering this MSDTC. Great. We've created it. Everything looks great. But I haven't taken care of the Azure piece of things. This still won't work if I actually attempt to use it until I go configure it in Azure. That's the piece that we need to take care of. And we've pretty much already kind of walked through that, right? So what we're going to do is we'll go back to our load balancer, same load balancer we're using before. And what we'll do is we'll go in and we'll add some stuff in order to make this work. Now, when we originally created the load balancer the first time, it created the front end during the configuration. But I'm going to need to create a new one because this is for traffic coming in on the front end of this load balancer for IP 10.0.0.110, which is my SQL FCI. Well, now we're talking about our MSDTC. If I look at my MSDTC here, I'm going to notice that my IP address happens to be 10.0.0.115. So I need to create a front end for 115. So let's do that. Click Add, and we'll do MSDTC is what we'll call this. The subnet, of course, is perfectly fine. That's the only subnet that I have. That's default. Now the assignment here is not dynamic. We'll use a static and tell it exactly what the address is. So 10.0.0.115. So it's going to save and deploy that as the front end. While it's doing that, we can go take a look at the back end and see what we need to do on the back end. Now, the back end here, I don't actually need to create another back end because I'm using the same back end. It's the same two, RA-test4 and RA-test5 that I'm using here. So I don't need to recreate this. We can reuse this backend pool because the pool is exactly the same. We're distributing it among 4 and 5. Okay, great. Well, what about a health probe? Well, it's a different network name, right? This probe port is for 59,999, which we configured on the IP address of the SQL Server failover cluster instance. Well, we need to create one for the IP address of our clustered MSDTC. So let's do that. We'll call it RA probe MSDTC. Then we need to go in and pick a port. I use 59,999, so let's use 49,999 this time for this particular port. Interval and threshold default as they were before. That's perfectly fine. Now it's going to go in and create the probe port. And then the next to the last thing we do, at least last thing we need to do for the load balancer, is we need to go and create the load balancing rule. So it looks like it created a probe, just double checking here, it created a probe. My IP changes, okay, so I want to make sure all those changes have occurred before I attempt to create the balancing rule. And the rule that we're going to do here is, I'll call this RALB rule MSDTC. Now the front end we want to use, of course, is our MSDTC, our 115 address. And the MSDTC uses some ephemeral ports. And again, you can look that up, it's all documented, the ports, but it's a big range of ports. What we can actually do here, though, for this is we can actually just check this box for HA ports. So we don't have to specify the ports. Now, there's a lot of advanced configuration you can do. You can go in and restrict the ports that MSDTC can use so that range isn't as wide. But here, we're just going to use the HA ports. That way, it go ahead and covers the default ports. Our exposure here from a security standpoint, for those that are thinking about this, is we're inside of a VNet inside of Azure. There's not a public IP address that's exposed for this particular VNet. So I don't really need to worry about my exposure here because this is all secured within a VNet. And this is a load balancer that's internal. It doesn't have a public facing. So I don't need to worry about it as much. I can just use my HA ports here. It knows what those are. The backend pool, of course, I use my RA pool. Didn't need to create a new one. We're reusing that. Probe port we need to change here, though. This is using the FCI probe port. We need to use the other one that we created. So it looks like that probe port save didn't quite go through yet. So let's go ahead and back out of this. And this is something you're going to run into too. If you get carried away and you start doing this a little too fast, some of these things might not show up. Probe port is here. So let's attempt to go in and create another rule. Let's see if it shows up this time. Hopefully it does. There it is. Give it that name, RALB rule for MSDTC. My front end again was 115. HA ports checked off. RA pool for the back end. Changing my host probe ports, now the 49,999. Session persistence is none. 4-minute on the default timeout. And we do need to make sure that the direct server return is turned on. And we go ahead and click OK there. And once it saves that and that works and goes through, my configuration will be done here on the load balancing rule. Now, the other thing, of course, remember is we need to go configure that probe port inside the cluster. So let's make sure we go take a look at that and make sure we get that right as well. So we'll go back to PowerShell for that. We need to change some of these names. Cluster network 1 is the same, right? It's the same cluster network. We didn't change that. We do need to make sure we get that IP address name right, which we got wrong last time. So we'll go in here, we'll do properties on the IP address for that cluster. And it's called ClusDTC. I'll just copy and paste it out of here. And we'll paste that name in right here. The ILB IP, of course, is not 110, it's 115 now. So we're looking at the MSDTC. And we chose 49,999. So we will change that. If we want to verify the config, we're also going to need to copy paste that down here just so we can go grab it. So this will go set that configuration for me. And then I should be able to, let me go verify that. I got a couple warnings in there, see if that actually worked. And it did not. So we want to make sure we get that right. Let's run the whole thing here. You know what, I think I clicked on the network name and got the name wrong. What I really wanted was the IP address here. There we go. That's the name I want. Sorry about that. Make sure we get that right. Go ahead and paste that here and here. Go ahead and run the configuration part. Again, properties restore, but not all changes will take effect until that IP address is taken offline and back online again. And just to make sure, there's my probe port right there. So we've got that properly configured on the IP address resource for the MSDTC in the cluster. But we need to go ahead and move this guy in order to take him off, or we just take him offline and back online. So we can do that, right? So we can just do stop the roll. And then we'll start the roll back. That will bring everything back online. That way that probe port will take effect at that point. So this is great. Everything looks good. But we really want to verify that this actually occurred. And we can use DTC ping, but there's another way that we can do this. And let me show you that. So component services, if we run that and we take a look under distributed transaction coordinator, I'm going to see that I actually have two here. Here's my local MSDTC. Here's my clustered MSDTC. And what I really want to see here is if I use from a client perspective a distributed transaction, I want to make sure that it does not come in here, and this will show us the transactions as they come in. I want to make sure that they're coming in here on the clustered MSDTC side to verify that this does indeed work. Let's check that out. So I want to go over here to my client. And what we're going to do is I want to create a database. And this is just a sample database. Of course, there was a disconnect, reconnect there, so we'll reconnect and run this. This is going to go create a database. It's got a single table in it, but that's what we're going to be able to use here for our demo. And there's nothing major in here, right? It just creates one table, just something that we can query because we just really want to create a distributed transaction. Refresh, here's my database sitting on my cluster. So let's play around with the distributed transaction piece here. Let's make this much bigger so that we can actually see it. So what I'm going to do is a begin distributed transaction using my example database. I'm going to select the top 100 records out of my excerpt table. And I have a rollback and commit. So I'm going to comment out the rollback. And we're actually going to commit this transaction. So we're just going to run this. And let's see if we can put this on the screen at the same time, hopefully. So I'm going to move this over to the right. Move our MSDTC over here. So let's go ahead and execute the query. I can see that it did indeed return. And then over here, I do see that yes, indeed, it did turn green. I did have a committed transaction here using the clustered MSDTC. Excellent. Well, let's make sure it runs with a rollback. So it'll run through the transaction, it'll roll it back. Let's see if that works. Execute again. And now what we see is I have an aborted transaction now. So I see that I have a committed transaction and aborted transaction. Great. All using my clustered MSDTC over here. What happens if I fail over? Let's fail everything over from one node to another node. Let's go ahead and move the MSDTC. Go ahead and move SQL Server. Wait for all that to come back up and running on node 5. So we were running on node 4. Now we can see if we look up here, both of these roles are now running on RA test 5. So SQL Server is almost done coming online, and now it's done. So we've failed over. Let's bring component services back up into view, and let's repeat this test. So we'll do the commit first. Go ahead and execute that. Result set comes back, and indeed we can see I did get a committed transaction over here. Excellent. Let's try aborting one by rolling it back. Let's go ahead and execute that. And sure enough, we can see that I do indeed have an aborted transaction. So we have now configured a 2-node failover cluster instance inside Windows Server in Azure. We've configured storage spaces direct, or S2D, for our shared storage in the cluster. We have presented that storage using a clustered shared volume. Okay, all these multiple different technologies all coming together. We put a SQL Server failover cluster instance on top of that, right? And we added the second node, and we have 2 nodes there. We configured our load balancer for both the FCI and for the MSDTC, created the MSDTC, a clustered MSDTC, and then we used a client to actually test and verify that this would work, and it would be our transactions inside of a clustered DTC would actually be pointed to the clustered MSDTC and not the local one. That way we can survive failovers. I hope this video has been useful for you. Again, I'm going to put the link up here for the walkthrough blog post that kind of walks through the details. It has links because we're talking about a lot of different technologies here. We're using a lot of different technologies, bringing them all together in order to come up with this solution. So I will put that link, should see it down here at the bottom for you. That way you can go look at the additional details. There's screenshots out there and links to all the different things about S2D and how do I clear off, where's the code to clear off all of the drives and all that kind of good stuff is all out there for you. So I hope that you have found this useful.